Hello, my name is Joan Shaiju, and me and Mason are going to teach you several sorting algorithms you need for the AP exam, and one other one that would be easy for you guys to understand. The three that you need for the AP exam are selection, insertion, and bubble sort, and we're also going to teach you bogus sort because it's easy for y'all to understand. So let's start with selection sort. So it's called selection sort because it repeatedly looks for the next smallest element in an unsorted array and swaps it into place, which makes this have a time complexity of O of n squared, which makes this really simple to think and to do in code, but it doesn't make it as efficient as more advanced sorting algorithms like insertion sort, merge sort, etc. So if we look at the code here, you can see how we look through the unsorted data for the smallest element in the array, and we swap the first element of the unsorted data with the smallest value in the array that we first searched for. So we swap it here, just like in bubble sort, which you'll later learn we have a temporary index, a temporary integer, which holds the index, and we swap the positions. Now we have bogus sort, otherwise called as monkey sort, permutation sort, and slow sort, which randomly keeps shuffling the value until they're in order, which makes this extremely slow, and it has a big O, a time complexity of O n minus 1 times n factorial. This is terrible, and as an easy way to think of this is have a deck of cards, hoping that they get in order. You just throw them up into the air, and if they don't land in order, you just keep throwing it into the air. So that's bogus sort, selection sort. I'm going to show you a demonstration of both of them using cups, and Mason's also going to explain the other two sorting algorithms.
Okay, so here we're going to do selection sort. So you can see how we have a list array size of 5. We have index 0, we have a 5, index 1, we have an 8, index 2, we have a 1, index 3, we have a 3, and index 4, we have a 6. So let's do selection sort on this. So let's look for the least smallest value or the minimum value. So just 5, 8, 1, 3, and 6. Well, 1 is the minimum, so it switches 5 and 1. Now we go to index 1. So let's look for the smallest value. 8, 5, 3, 6. 3 is the smallest. So we switch 8's position with a 3. Now we go to index 2. 5, 8, 6. Well, 5 is the least value, so it stays there. And we have 8 and 6. Well, A6 is less than 8, so it swaps. And that's how you do selection sort. Okay, so now we're going to do the most inefficient and the worst way to probably code a sorting algorithm. It's bogus sort. So let's do this. Randomize this. Is that sorted? No, it's not. Is that sorted? No, it's not. Is that sorted? No, it's not.
One eternity later.
After 10,000 runs and nearly killing our computer, we finally did this. We finally sorted it using bogus sort. Yay!
First, we're going to start off with bubble sort. Bubble sort is one of the most inefficient sorting algorithms that is taught in AP, but it is one of the simplest because all it does is swap adjacent elements throughout an array one pass at a time. So first we're going to start with an array of 5, 3, 8, 4, 6. The first elements that are out of order is 3 and 5, so it's going to swap those because they're adjacent. So it's going to be 3, 5, 8, 4, 6. Next, since 5 and 8 are sorted, it's going to go 8 and 4. It's going to swap those, 3, 5, 4, 8, 6. Then 8 and 6, you can't go back, so you got to do finish the pass. So 8 and 6 need to be swapped. It's going to be 3, 5, 4, 6, 8, and the final swap is going to go back and do 5 and 4. So the final array is 3, 4, 5, 6, 8. Next, we're going to do insertion sort. Now, insertion sort is probably the fastest of the three algorithms you need to learn in AP. And what it does is it grabs an element and drags it backwards until it fits into the array sorted. So we're going to start with an array of 5, 3, 8, 4, 6 again. 5 is already sorted. So it's going to grab the 3. It's going to drag the 3 back. And since 3 is less than 5, it's going to be 3, 5, 8, 4, 6. Next is 8, but 8 is already where it needs to be. So it's going to ignore that and go to 4. It's going to drag the 4 back from 8 and the 5, so it's placed before the 3, so it'll be 3, 4, 5, 8, 6. Then it's going to swap this 8 and the 6. So the 6 is now in place. So now it's finally sorted.